Hey everybody, Scoutcrafter here. Well, you've been waiting patiently, and here it is. We're going to do a quick introduction to the milling machine. By no means am I an expert, but this is meant for people that have no idea what a milling machine is or what it does, and maybe it can just shed some light and take away the mystery. So let's get right into it. The first thing you're going to notice about a milling machine, or many milling machines, is that they're very similar to a drill press. And there is a lot of features in common, and they do a lot of the same jobs. Although the one big difference is milling machines have a sliding table. They have a tower that goes up. It could be round, or this one's dovetailed, and it holds the head, which has the motor, and it spins a spindle. So it's basically a very simple machine. The big difference between a milling machine and a lathe is the lathe takes the work and spins the work, and the cutters are stationary. With a milling machine, like many other machines, the work is stationary, held tight, and a spiral cutter does the work. So that's your two basic differences in a lot of the metalworking machines. Now, one thing you have to know about milling machines is there's three things you look for when you're looking for a milling machine, and that's rigidity, and rigidity. That's your key. You need, whenever you're working with metal, that's why you really can't use a drill press to do operations that we do on a mill, because a mill is so much stronger and meant for it, and I'll show you why. Now, the mill I'm going to show you it's called a mini mill. They do make a micro mill, which is smaller, but a mini mill is a smaller, just like my mini lathe. But they also have, as you get bigger in lathes, you can go all the way up to a Bridgeport size mill, and even bigger than that. The size all depends on how much of a cut you can take. They all basically do the same thing, but a big mill will take bigger cuts. A small mill has to take smaller cuts. But if you can work on this, and you can work on a big one, they're basically all the same. Now, first, we'll start off with the table. Most mills have what's called a slide table, or a milling table, and basically what it is, it's a table. This one has a vise already mounted to it, but it's a table that accepts remember those T-nuts and hardware to clamp something down? That's what this table does. It moves two ways. It moves in and out, and that's called the Y-axis. It moves to the left and to the right, again using these hand wheels. This is called the X-axis. And then the last movement we have is when the head moves down like this. Just let me unlock. When it moves down like this, and that's called the Z-axis. Now, behind the sliding table, we have, this is called the column. Now, the column can tilt left or right. Usually, we always leave the column alone, because once you get it trammed in where it's perfectly perpendicular to the table, you kind of want to leave it. But every time you move it, it takes a while to trim it back to get it accurate, so you kind of leave it alone, and you do your work on the table. You put blocks and things like that. Over here, very similar to the drill press handle, instead of it lowering a column here that comes down, this lowers, you could see the whole head, and you can see how this will lower down like that and up, and that makes it for a much more rigid unit. Now, on your bigger mills, they also have a column that could go down, just like the drill press does, but the column is much thicker than this. You can see here, you see that little bit of movement? You can feel it when you move it back and forth. It's just a little bit, but there should be absolutely no movement. Again, rigidity, 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 and that's why they got a big column on those bigger mills. On the small mill, like I have, they did away with that because it would be too expensive. Okay, lastly, on the top of the mill, we have our motor, which drives a gear. There's gears in here that drives the spindle, and the spindle is what holds all your tooling, and we'll get to that in a minute. And to turn on the mill, basically you lift this safety switch up, and that engages the power, and then there's a variable speed here that'll engage the spindle to make it rotate. And that's basically all it is. There's a forward and reverse, and it's a very simple machine to operate, extremely simple. Now, here's where the fun comes in. This is the spindle, and what this is nothing but a little round tube that runs from the motor, the gear drive here, that goes down to here, and there's a little hole here. Now, this hole is different sizes for different machines. The big machines, like a Bridgeport or something, might use something called a R8 and that's an R8. That's the size of the tooling that goes in here. This one here uses what's called a Morse taper 3. Just for size comparison, this is a Morse taper number 2. This is a Morse taper number 3. You can see about the size difference. And, you know, it goes down. There's a Morse taper number 1. It, you know, goes down and goes up. And this is a R8 collet, which is what the big machines usually use, something like this. But you see, again, the size difference. The bigger the machine, the bigger, the thicker, the rigidity. Now here's where a milling machine tends to differ a little bit from a drill press. Again, we were talking about rigidity. Now to mount the tool into here, there's that hole in the spindle. You take this little cap off up here. Now there are, you know, some will have a bolt, they have different setups here, but basically it's something to tighten down and draw the tool into this little tube that's here. And right now we're going to mount a drill press, and you can see it has the drill chuck on a Morse number 3 taper, Morse taper number 3, and there's a little, they call this like a drawbar, a little bolt that goes into the top. And what you do is you take your, in this case, the drill chuck, you press it in here, you drop it, will pretty much stay in by itself, but this is to ensure it, because when we're working with metal, you have to have rigidity and solidness. You tighten that down. Now on this particular mill, you take a ring spanner and you grip it on the bottom nut here, and then you take a regular wrench here and tighten up and bring it against each other until it's snug. It don't have to be super tight, but just it's snug. Now that isn't going anywhere. That's a solid connection. Now you can see we mounted the drill chuck, and this little nut will spin when we turn on. You can see when we turn on the mill, that nut spins, and that's why this little cap is on here. I guess because it could be a little intimidating to somebody to see that nut flying around there, so they put that little cap to cover it. But you can see now that the chuck is spinning on here, and that's your drill press if you want to use for drilling operations. Now what I want to point out real quick is a lot of times on these Asian chucks, you'll see the outside covering here, this little part that you grip, might be a little wobbly looking, and that might make you think that the chuck isn't so accurate. But what you have to do to see how accurate the chuck is to mount a rod in there, and then to check the bottom run out from here. So let me show you what I'm talking about. Here you can see it looks like it's wobbling a little bit on top, and you say, wow, that's out of round. But if you look closely at the bottom here, you can see that this is running very true. So you don't judge a chuck by its cover. Now, you already know that if for most of the parts that we want to make, any kind of time you want to make something out of metal or whatever, if you want to make things that are round like this, you could do this on the lathe, because this, you would chuck it in here and you would turn this down, turn that little groove down. You could turn this inside groove, the outside groove. This is all done on a lathe. Whereas when a piece like this, you would do on a milling machine. You would take a big piece. You could see this was a square piece of steel, and you know, this would be the cutout with a bandsaw, but then you have a rough edge, and you'd smooth this side down, drill these holes, and again, by using the table, you can get a very accurate placing of these holes. So that's what you use a milling machine for parts that are like squarish or flat or things like that. And round parts get done on the lathe. Now, some of the cool tools that you can use on the milling machine, this is called a fly cutter. And a fly cutter is basically, this goes into the machine, it spins around, and when it does, you can see this will make a big swipe and give you a clean off the surface of whatever metal you have on there and make it very flat and very nice. This is called a boring bar. And if you have a hole that you need to have enlarged, or a big hole like a 3-inch hole, you can't do that with a 3-inch drill bit. You know, not many machines. A-bomb could do it, but we can't. So use a boring bar, and you put a cutter in here, and it spins it around, and it'll take the edge off the outside of a small hole and make it bigger. And boring bars you can use for a whole bunch of things. Now, when a machinist looks at something and he says, I want to make this part, there's a lot of different operations involved in making this part, but he looks at all the different pieces he's going to need to make this, like this little groove here. He's going to have to make that groove with a special tool. This groove here, the side groove, he's going to have to make in. You can see it dips in here and then it comes up. And these slots here and the grooves along the edge here, these are all done usually with tools called end mills. And end mills, there are a whole bunch of types, and you shouldn't store them like this, but this is just set away. I don't usually use these all the time, but end mills are pieces of usually high-speed steel, but you can also have cobalt, things like that. But you could see this will make a cut, and it's all measured out here, and over here you could see the size, 7/32. So this will make a 7/32 groove. This is a twin flute. There's all different types. You can see this one here is called an end mill, and it's a 4 cutter. You can see there's 4 cuts, and you can also cut on the side. And this is a double end mill, so if one gets dull, you can flip it around, so you know you get more money out of your tool with a double end mill. But to hold an end mill in the mill, you need either an end mill holder, which looks like this. It has a screw. You can see that slips in, and it will catch on that little cutout that we have there. Or you can use a collet, and this collet is set up just for certain size end mills, and when you slip that in there, if it's the right size, it'll close in. And let me show you how that goes. Now this is a 3/8 inch end mill holder, and you can see a lot of end mills will go up to a 3/8 inch shank, so you can use something like this. And this is a 1/2 inch. You can see this is a 1/2 inch end mill, and this is a 1/2 inch collet. And when they fit in here, it's such a snug, perfect fit. I mean, there's no play whatsoever. When you tighten that up into the collet, this is a very secure hold, and this is very accurate too. So a lot of people prefer collets over end mill holders, but let's put them in the mill and see. Now, one important thing to remember, we're going to be taking out now, we're going to take out what we put in before, the drill chuck. But to remove the drill chuck, after you loosen this up, you have to tap it with a hammer because it will not release on its own. And a lot of new timers to the mill get confused now with this. Take out the any tool that you have in here, you're going to put your ring spanner on here. You're going to loosen it up, and then you're going to loosen it up and take it about 1/8 of an inch to let that above it. And then you're going to take a metal hammer. It's got to be a metal hammer. You can't do it with a soft blow. And just tap the top of this. Okay, and it loosened up. And once it loosens up, then you can unscrew it. But if, I remember when I first got the mill, I was wondering why it wasn't coming out. Now, using the same drawbar bolt, we're going to put our collet in where we had the chuck, and we're just going to press that up in here, place the bolt down here, and we're going to tighten it up with the 2 wrenches. Okay, now we have our end mill mounted in the collet, and it's nice and secure. Now we're going to mount our piece of work. And what we're going to use here is, I just have a piece of scrap plastic, and we could do aluminum, we could do steel, but I'm going to show you, you get a better view when we use something soft like this. Now, a lot of times when it comes off the saw or anything, you'll see these marks and stuff. You want to make it smooth, you want to make it nice, you're making a part or something. Same thing with aluminum. But I'm going to show you the kind of things you could do with here. So the first thing we'll do is we're going to mount this into the vise. Now, this vise that they use for milling machines is a special kind of vise. It's not like a cheap drill press vise or something like that. How this works is when you tighten this up, it actually, a lot of vices, when you operate them, if you go to tighten a vise up, it tends to push the work up and it'll make for an inaccurate cut. This particular vise, as you tighten it, it draws the work down against the base, and it makes for a very accurate cut. This is one of the most important accessories for a mill. Now, to mill off the top of this, if we wanted to, let's say we want to take 1/8 of an inch off or smooth it off if we had a real rough cut, the first thing we do is we bring down the head with the cutter, and what we will do is we'll bring it down to touch the piece here. We'll touch it here, and then you could, there's a little knob here. Now, if you want to use this and measure exactly how much you're taking off, this particular machine, what you would do is you would take this handle, and you see the little gear, you would push it in and engage, just like that, engage that gear, and now you can use this little knob here to go up and down. Now, there's a little lever back here for low speed or high speed. If we were using it for very difficult material, we'd leave it on low, but since we're doing plastic, we could put it on high, it'll spin fast. Okay, now we're just having some fun, so I'm going to bring this over here, drop the bit down just a little bit so that we just take a little bit off, and then I'll pass it back and forth, and we'll see what kind of surface we get. Okay, now you could see, we're going to loosen it up, take it out of the vise here. Now you could see, although the surface is flat, it's very flat, the surface that an end mill leaves is always, you're always going to have these little lines, and that's why it's not, but it's good for roughing out to get down to that line that maybe you want to get to. But now what we're going to do is we're going to put a groove in there. Let's say we wanted a groove because we're making a part, and let me show you what that looks like. Okay, let's take a look at what it looks like now. Loosen it up, take this out apart. You can see, now plastic always leaves a little bit of burrs. You'd have to take a little scraper or something, a screwdriver, anything to just pull that plastic burrs off. But you can see, if we want to make a groove in a part, this is how you would do it, you see? Now let's say we want to put a groove in the side here, because the end mill can cut on the side too, and let me show you what that looks like. Okay, again, you can see that it makes a lot of shavings and whatnot, but here it is. We just made a small groove on the side there. Now, again, plastic, you have to deburr it as you would take it off because of the shavings it leaves. We'll do a little bit of aluminum later, but you can see here what it looks like when the part, we put a little groove in there. So if you want to make a part, you could see how you would do that using just that one end. Now here I replaced the straight end mill with a ball end mill. It's shaped like a round, and we'll just see if we can round off one of these corners here using that ball end mill. Now, using different adapters, here is a Morse Taper 3, which goes into our mill. This is adapted to a FMB22 holder, which is, you can get a lot of tooling like this overseas, inexpensive. This is a, you can replace the cutters here, and you can turn them around, so you get a lot of wear out of this, very strong. And you can see there's a keyway in here, just slips onto here like this, and this little bolt here will secure it on. And let's see if we can't get this surface here, this rough surface that's done by a saw when they cut this. Let's see if we can't smooth that out using this cutter. And you can see what we just did here with that little curved surface there using that ball mill. Now, in order to raise the work above the jaws of the vise, if we tried to put the work in there, you see it's too low. We use a set of what's called precision parallels. They're exactly alike, and they usually come in sets, and we put them here like this. That'll raise the work up here so that when we tighten it down, this will run above and not hit the vise. Now, since we're only going to be using the X axis, we will use a lock just like this for the Y that's underneath, and we will lock that down so that you don't have to worry about, again, rigidity. Now, you can see how these chips tend to melt together. You know, this isn't the ideal machining plastic, not like Delrin. Delrin's much better, but you can take a look here. See, that's just the chip, the shavings just come off. But you see the finish here that you get with this multi-head cutter, and you can see how absolutely flat it is. And you know, you can by varying your speeds and feeds and adding lubricants and things like that, you can change the finish. I know I'm running a little bit long, but this is just too cool not to show. Let's say this is called a collet block, and let's say I wanted to put a head on here, like a bolt head. You know, let's say I was making a bolt. What you do is you take your collet, and you see this is a 3/8 collet, this is 3/8 in stock, and we put the piece of stock in here, and then we put it into this collet block here, like this. And then once it's in here, we tighten up the back here, and we put it in the mill, and watch what happens. Now you can see it's a 6-sided collet, so we locked that piece in there that we wanted to put the hex head on. So now what we're going to do is we're going to run it back and forth. Let me show you what it looks like. Okay, here you see what we did. We now loosen this up. Loosen it up to about here. Give it a slap. that'll loosen the collet up, because like I said, they tend to get stuck in there. Pull this out like this, take out our piece of stock, and look what we put. We just put a hex head on there. Now again, you got to deburr it anytime you work with metal, put sharp edges, but you see what we did? Now you can, that's what's so cool about a milling machine, little things like this that you can do, and just a lot of fun. One other feature, if you want to make holes, you know, on the drill press, we have the depth stop. They have the same one here, and it's what it is. It's a little bar that goes up like this, and you could lock it down with this little gib right here. You tighten it down, and then when you bring down the head of the milling machine, it'll always stop at exactly the same point. So that's a normal feature on all the machines. So in closing, I'm sorry if I went a little long in this video, but there was so many cool things. I only covered 1/10 of everything that these machines can do, but I just wanted to give you an overview, especially if you've never seen one, have no idea. Super simple to use. Don't be intimidated. It's just like a drill press. If you never used one before, they seem, but there's the easiest things to use, and a lot of fun. And I hope you enjoyed the video. Thanks so much for tuning in. Take care now. Have a nice day. Bye-bye.